So, as promised, we'll be looking at the next example. We just did this one, the first one. So the one here at the bottom we're going to be looking at. So in this case, they're talking about the combustion of this compound called isopropyl alcohol, which is the same thing as rubbing alcohol. And this is the equation. So they gave us the balance equation, and they also gave us the enthalpy of the reaction under standard conditions. So it says use this equation, and using the same table that we used in the previous problem, we need to determine the standard enthalpy of formation of isopropyl alcohol. So it's pretty much the same thing as what we did before. The only difference is that in the previous example, we were asked to determine the enthalpy of the reaction, right, under standard conditions. Here, they gave us the enthalpy of reaction under standard conditions. But in this case, they're asking for us to determine the enthalpy of formation of this. Whereas in this case, they gave us the enthalpy of formations of all the substances involved in this reaction here. So it's the same concept, but of course, they're asking for something different, all right? So what I'm going to do here, I basically copied and paste that equation to the next page here so that we can do the problem solving here. And again, what we need to do is look for the values of the different substances in the table that I showed you, the thermodynamic data table. Okay, so let me make sure this is the right color. My preferred color is black. Okay, so this is what the question is asking for. The question is asking for the enthalpy of formation of isopropyl alcohol, all right? You notice that there's a 2 here. So basically, if we did know what this value is, we'd have to multiply its value by 2. So I'm going to write 2 times the enthalpy of formation of isopropyl alcohol. Now, what I'm going to do, because I'm lazy, I'm going to use an abbreviation here. I'm going to use IP to represent the enthalpy of formation of, to represent isopropyl alcohol, all right? Okay, oxygen by itself, it's an element, not combined with anything. So guess what? Its value is 0. So 9 times 0 kilojoules would be the total amount of enthalpy of formation provided by the oxygen. Then we get to the carbon dioxide. So according to the tables here, which I have right next to me, carbon dioxide, the value for it is minus 393.51 kilojoules. And because, kilojoules, and because we have a 6 here, we have to multiply that by 6, all right? And then finally, in the case of water, okay, so I have to search for water, the value for water. Okay, for water, let me check the state, liquid, okay. So for water, the value is 285.83 kilojoules. And because of the 8 here, we have to multiply this by 8, right? And then we find the total sum of this here, which would be basically 2 times the enthalpy of formation of isopropyl alcohol. And then we have to find the sum of all of this here. So let me do that calculation here. So 393.51 with a negative sign in front of that times 6 plus 285. Oh, by the way, I think I made a mistake. Yes, I did. This should be minus 285. So this should be a minus sign here. All right. So minus 285.83 times 8. So according to my calculations, the total on this side would be minus 4,647.70 kilojoules, all right? So remember now, to calculate delta H for the reaction, which is equal to this, delta H for the reaction would be equal to the sum of the enthalpy of the products, which is minus, in this case, minus 4,647.70 kilojoules minus 2 times the enthalpy of formation of isopropyl alcohol, which would be equal to what is given here, which is minus 4011 kilojoules. And basically from here, it's algebra. We have to solve for this. We have to isolate this. So that means that I would add plus 4 647.0 to both sides, plus 647.70 to both sides, so that this would go, and you're going to end up with minus 2 times the enthalpy of formation of isopropyl alcohol equals to whatever this gives. So let me do that calculation here. So minus 4011 plus 4647.70, and the answer I got here is 636.71 kilojoules. So that means that delta HF, hold on, down here, delta HF for standard, I should put the little O here, just to be accurate, for isopropyl alcohol is going to be equal to 636.71 kilojoules divided by minus 2. So when I divide that by minus 2, the answer I got is minus 318. Let me write that down here. Minus 318.36 kilojoules. And that's basically how that is done. All right. Okay. So that's basically the second example. And that represents the end of chapter 6. All right. So we're going to move on to chapter 7. And that's it. All right. So of course, if there are any questions that you have to ask, please let me know so that I can deal with any issues, any problems, any difficulties, and so on. All right.